I'm just going to be solving some miscellaneous problems in Codeforces, starting with this one, expected damage. Cool. Um, nice. Let's see if anyone is watching. Feel free. Okay. So I read this problem a little bit ago, and basically what you're doing is you're playing this game where you have n monsters, and each monster has some strength. And oh, by the way, let me know if you can hear me and see me okay. I just want to check my stream quality is working well. Seems like it's a little weird. Yeah, it says average stream bitrate too high. Everything is good? Okay, cool. Yeah, the Twitch dashboard is showing me some unstable notification, but it's probably fine then. Cool. So yeah, let's read this problem. Let's make the whiteboard a little bigger. So we're going to make heavy use of that. All right. So basically, you have to pick a shield, and then given your shield, um, you have to figure out the expected amount of damage you'll end up taking. Oh, thanks for the follow, DUSH1729. So, all right. So this is an expected value problem. So without even thinking about the problem too much, just as a spoiler, we're probably going to want to use some form of linearity of expectation. That's basically the most powerful identity or fact when you're doing these types of problems. That allows you to just break it down however you want to make it as simple as possible. But I guess let's start by going through an example just to make sure we actually understand the problem. So let's see. So if you have no durability left, you get... Okay, so when your shield runs out of durability, you run out of... Okay, once your shield runs out of durability, you take damage from all the remaining monsters. And when your shield still has durability, it decreases only when you get hit by a strong enough monster. Cool. Hmm. All right, and their first example, they have 3 monsters. Okay, so let's try... oh yeah, exclamation mark problem doesn't work, but I have exclamation mark link. It's a little more general than problem, I guess, because it could be a different link. Sometimes it's a link to a contest. I'm doing a whole contest. So in this example, let's see, we have 3 monsters with strengths 1, 1, and 3. The order doesn't actually matter because you have to consider a random order of the monsters anyway, so you might as well sort the input just to make it easier. If that ends up making it easier, that is. And then let's try the second example, because the answer is just 1. It looks a little simpler. So in the second example, your shield strength is this A and B is a little annoying. You have to look up what each one is. Okay, so the durability in the second example is 1. And then the strength is, or I guess it's defense. The defense is 2. And so then the expected damage you take is 1. Okay, so what happens here is basically if you get hit by one of the things that's less than 2, either of the ones, then nothing happens. And then if you get hit by the 3, your shield breaks, but you don't take any damage. And then you end up getting hit by all the ones that are after that 3. So basically what we're looking at in this case is you want to permute 1, 1, 3. So you could have 1, 1, whoops, 1, 1, 3, 1, 3, 1, 3, 1, 1, and in this case you take 0 damage, 1 damage, and 2 damage. So the expected value is 1. Alright, now let's try the next example where you have defense 1. So in that case, your shield's defense, Cabo 25 says hello, sir. Hey. Um, by the way, I think so. This problem is a educational round E, so it's probably going to be pretty tricky. It's not like one of those just solve it and you're done problems. So, I'll write shield again. Okay, so in this case, if we have durability 2, then and defense 1, then everything will hurt our shield. So basically the first 2 hits to hit your shield will break it, and then you'll take damage from the last hit. So if it's 1, 1, 3, 1, 3, 1, or 3, 1, 1, here you'll take 3, here you'll take 1, and here you'll take 1. And then that gives you an expected value of 5/3, which we can check on Wolfram Alpha. Let's see if this actually, I've never actually tried this, but let's see if it does it. Wow, okay, that's not really, I guess I can just check the answer instead. Okay, cool. Yeah, so this is 5/3, so we understood the problem correctly. Okay. So I think for a given shield, okay, so this is like the simplest way to think about it, where you just consider every ordering of the monsters. Now the way that I want to think about it, I'll start a new page, is I want to figure out how much damage each monster will do to the shield. So in the case where we have durability 1, defense 2, then the 3 monster will never do any damage. and the one monster will do 1/2 damage because it could either be before or after your shield breaks, and the other one monster would also be 1/2 damage. So then that gives you a sum of 1, which is the correct answer. And then for the 2/1 shield, the 3 monster has a 1/3 chance of being after you break your shield, which would be at the very end. So that would be 1, which is 3/3. And the one monster would be 1/3, and the other one monster would be 1/3. And that gives you 5/3, which is what we wanted. Oops. All right. Cool. So let's see if we can use this to come up with a solution that runs in time, or at least runs in like polynomial time or something, so we can make sure we kind of have a starting point to go off of. Can you explain 2/1 example again? Yeah, sure. So in the 2/1 example, your shield will break after 2 hits. So the only way that a monster can damage you is if it's in the 3rd position, and its chance of being in the 3rd position is 1/3. So that's why each of these 3 monsters has probability 1/3 of doing damage. So this one is 3 times 1/3, this one's 1 times 1/3, and this one's 1 times 1/3. Cool. So I think this is a promising approach. So for a given monster, awesome. Yeah, I'm glad that helped. So for a given monster, we want to find the probability that it damages you. And then we can multiply those by the strengths and then add them all up. So what's the probability that a monster actually does damage to you? It's the probability that... I'll go to the next page. Should I link this whiteboard in the chat? Would that be helpful? Let me figure out how to do that. Cool. Could someone see if those links work to actually look at the whiteboard? Just that people can look at previous pages if they want to go back. Cool. All right. It looks like it does work, and a bunch of people are viewing it. That's cool. Yeah, just because it's a little bit tough because I want to go to the next page, so I have space, but then I don't want to hide everything from the previous page because, then it would be a lot harder to follow. I should start sharing the Jamboards for all my for all my streams. Okay. So let's see. What do we want to do here? So probability that a given monster damages you. So this is the probability that a monster is after a other strong enough monsters, where strong enough means they do more than B damage. So let's say we have K strong monsters, not including the current monster, and N monsters total. So then we want to find the probability that we are after at least K, sorry, no, that we're after at least A of these K monsters. Um, so actually, I think the total number of monsters doesn't matter. What we want to do then is consider all orderings of the K strong monsters plus our current monster. Then we want our current monster's index to be after A. Have at least A spots to the left. So the probability of that would be, basically we don't want it in one of the first A spots. So that would be 1 minus A over K plus 1. Where A over K plus 1 is the probability that our current monster is in the first A spots. Cool. So we can compute this for every monster pretty easily by just counting the number of strong monsters and then, adding or subtracting one, or sorry, yeah, subtracting one depending on whether the current monster is a strong monster. And that would allow us to solve this problem this leads to an O of n times m solution, because we'd have to do this completely separately for every shield. But let's code this up just to make sure that we understood the problem correctly. Okay. Does O of nm lead to TLE? Great question. I kind of brushed past that, but yeah. So O of nm would lead to TLE, and the reason for that is that nm are less than or equal to 10 to the fifth. Actually, 2 times 10 to the fifth. So then this would give us about 4 times 10 to the 10th operations. And my rule of thumb is that less than or equal to 10 to the 8th is good, and greater than or equal to 10 to the 9th is bad. So yeah, O of n times m would definitely lead to TLE here. One second. Whoops, okay. Cool. So yeah, just reading the input, and then shields. Oh, on in streams. Yeah. Welcome to the stream, and definitely make sure you follow. Oh, Gupta Summer, thanks for the follow. Completely unexpected. Awesome to see. So let's see. Okay, so let's figure out how to compute the damage for a single monster if these are kind of its parameters. So first we're going to count the strong monsters. And we're going to subtract the current monster if we need to do that. Oops. And then the probability will be, I guess as we said here, 1 minus durability divided by strong plus 1. Oops, that should be a question mark. And then we're going to return the damage times the probability. And then let's see if this works. What is the arrow? The arrow means you point to the return type. You can actually not include the arrow, and this will still work fine. Sometimes I like to do it to be explicit, but C++ will automatically infer the return type, which is nice. What do I want to do here? Alright, let's see if this works. Hopefully I wrote this correctly. Okay, I did not. Let me take another look at this. So I'm actually going to try this small trick. Oh, okay, right. So these actually need to be mod nums to begin with. The problem here is that I'm using integer division instead of mod division. So maybe that's just the problem, but let's see. Yeah, so this prints 5/3 and 1 as expected. So let's go back to using mod nums and check. Okay, cool. So this solution's correct. Also, the way that I wrote this solution is actually O of n times m because I have this loop and then this loop, but we can easily optimize that out. Okay. Leibniz disciple, thanks for the follow. Are you a calculus lover? Is that the Leibniz that you're referring to? Cool. All right. So now we want to figure out how to make this faster. Um, if we could count this quickly, oh, I guess even counting this quickly isn't sufficient. We have these two loops that we want to optimize kind of both of them out, which is actually a bit tricky. Let's see. All right, so let's think of the contribution about from a single monster again, but now let's consider how it changes as the strengths of the shields change. So I think what we want to do is so what this does is it considers each shield, and then we consider each monster's contribution to it. Instead, I'm kind of interested in seeing the monster's contribution to every shield, kind of at once. And the reason for that is because this contribution will be almost the same for a bunch of different shields. The reason for that being um, just this count of strong would change. Yeah, I think that's really the only thing that would change between different shields. So, and for a given shield, hmm, but I guess you can't exactly factor this out that easily. Hmm. Excuse me. So this definitely works, but it, definitely could stand to be optimized a bit. So let's think, how can we do this? Okay. So I think maybe what we can do is we can think about damage saved instead of damage done. So we would replace this probability with 1 minus that probability, and then we would subtract the damage saved, and then we would start with the total damage being the damage done. Um, so let's see, that should still work. Okay, cool. So now let's kind of look at this again. So if you consider a single monster's contribution to a bunch of different shields, then you want to take basically that monster's probability of uh, sparing the shield or like not damaging the shield. You can kind of factor out this 1 over. I guess I have a k over here, so I'll use that. So a given shield's expected damage saved is 1 over k plus 1 times sum of damage. And there's a little bit of trickery here because some of the damages you want to. I'll write it like this. Or 1 over k times sum of damage. And the reason there's a little bit of trickery here is because k actually depends on the damage itself, whether or not we want to do this strong minus minus. But we can actually just split all the damage into two separate cases, whether it's bigger than that or smaller than that. And I think that should um, oh, I guess I actually forgot this. Actually, it shouldn't be 1, this should be a. But kind of the key point is that this a over k plus 1, or this a over k thing, is constant for a given shield. So we can factor it out. So let's kind of think about what this would look like in code. So the weak probability would be the durability divided by um, the number of strong elements plus 1. And the strong probability would be just this, because it would be strong plus 1 minus 1. Um, yeah, cool. And then I will and I think we're going to want to sort the damages. That way, some prefix of the monsters will be weak, and then a suffix of them, the rest of them, will be strong. So I'll make this a little bigger so it's easier to read. Okay, cool. So what we want to do here is we want to find the first monster that's strong. So what this will tell us is like how long the prefix of weak monsters should be. So we'll do that using a binary search. So this tells us the first monster that is greater than or equal to defense. So wait a second. What did I do wrong here? Oh, mod num should be an int. All right, cool. So these are unused. Okay. So then we want to do I'll delete this compute. I'll leave it there for now. Okay, cool. So this also passes, and this is almost the right runtime. The only thing that's stopping it from being the right runtime is this loop here, where we compute how many things are strong to begin with. And I think we can solve that by... Oh, actually, this already tells us how many things are strong to begin with. So whoops. I have some other... Oh, okay, yeah. So this should be weak. I guess you have to look at equality. What do you mean, look at equality? Oh, yeah, like if the monsters have the same strength, then I think I... Wait. No, I don't... I think this should be right. Okay, I'm gonna try submitting this, and then... Well, first I'll check the runtime. So this loop is O of n, this loop is O of m, and then this binary search is log n, and then the rest of this is O of 1. So this should work. This should give us a runtime of, I'll write it down. O of n plus m log n. And this should be fast enough, since it'll basically be, it's like basically linear, right? All right, let's try submitting. Wow, my Chrome is really slow. I hope my internet's not out, though. I'm assuming it's not if I'm still streaming. Eloy HZ, thanks for the follow. Okay, it's finally loading the status page. I'm running on test 3. It was weird. I don't know why this is so slow. Ah, okay, cool. So I got wrong answer. I guess that's why the tests were running slowly. Doesn't really explain why Chrome was slow. Alrighty. So, where did I go wrong here? Oh, is it possible here for the probability to be more than the probability? So this probability can be, wait, is that right? So if strong is pretty small, yeah, okay. So let's try an example. I think there's this edge case where your durability is higher than your strongest, or it's higher than the number of monsters that can actually damage your shield. So like in this example, I'll just make this 1. In this example, your expected damage would be 0 because your shield's defense is 2, so only one monster can hurt it, but its durability is also 2, so it'll never actually get damaged. So I think we would want to print 0 for that test, and we probably don't. Yeah, we print like, this is like some negative number, modulo whatever. So So I guess this probability was, yeah, so I guess we can just check to see if the fraction is greater than 1 and special case that. Cool. All right, let's try submitting again. So that was a pretty tricky edge case, right? So the durability can't be more than the number of monsters, so you like almost think you won't run into that, but it can be more than the number of strong enough monsters, which is this tricky case that we ran into here. I guess now that we're submitting that, let's see what test 3 actually was, if it was exactly that or something else. Nice, so we got accepted, so I assume test 3 was exactly that, but I am a little curious. Okay, test 3 is really long, so never mind. But you can see here the correct answer has a ton of zeros, and we printed some numbers that are probably like something negative. Cool. All right. So that was the main problem that I wanted to solve in this stream. I was pretty excited to do it because it seemed like a fun problem, so I thought I'd stream so I could share it with everyone. Does anyone have any questions? Is today your first stream? This is like my ninth stream or something. Oh, I should plug my YouTube. My old broadcasts are on YouTube, so you should definitely subscribe there if you want to watch them. I try to make the videos there pretty watchable too by adding like chapter timestamps for each problem. All right, is Codeforces down right now? That would explain why it was loading slowly. Let me check it on my phone to make sure it's not like my home internet. Though, okay, clearly I'm still streaming, so my internet isn't out. Wow, so Codeforces is actually just down. Um, so that was actually super clutch that we got accepted right before Codeforces went down. If that's in fact what happened. I guess my browser's a little slow in general, so but it seems like it's not that slow. All right, well I guess it's back up now. Cool. Yeah, and I guess it's working for me as well. Um, okay. So if people don't have any questions or any other problem suggestions, I think I'll end the stream now. So thanks so much everyone for joining. Oh, and I guess before I end the stream, I'll do a quick plug. So I'm actually doing two streams tomorrow, which I think should both be pretty exciting. Um, wait, so is this just me? Or is this like it's like cutting in and out? All right. So I'm doing two streams tomorrow. There's an @coder beginner contest tomorrow morning, so I'm gonna do that and hopefully figure out how to solve most or all of the problems and then explain them on stream 5 minutes after the contest. And then there's a Division 1 round tomorrow at a super inconvenient time for the US. So Neil, Socket, and I are gonna virtual it as a team. So we're gonna collaborate on all the problems. So we're gonna stream that. So that should be pretty fun. Pretty casual, right? Because it's an individual contest that we're virtualing as a team. But yeah, definitely follow Neil. Sorry, follow me and follow Neil, and check out our stream tomorrow. And then if you like doing @coder, which I definitely recommend, especially if you're relatively a beginner, I think the beginner contests are pretty instructive. So then I'd suggest oh, the Christmas theme is back. Maybe that's why Codeforces went down. Um, but yeah, definitely check out these streams tomorrow if you can. Should be fun. But yeah, I think I'll end the stream now. Thanks so much everyone for joining.